Our sun is a star, a giant ball of burning gas. It is the heart of our solar system, providing the energy that sustains life on Earth. It's about halfway through its life, a healthy 4.6 billion years old. This middle-aged star has been shining brightly for eons, and it will continue to do so for billions of years to come. The sun might seem eternal, but like all stars, it has a life cycle. It was born from a cloud of gas and dust, and it will eventually die, transforming into a different kind of celestial body. For now it exists in a state of perfect balance, steadily fusing hydrogen into helium in its core. This fusion process is what keeps the sun shining and provides the energy that reaches Earth. This process of nuclear fusion is the engine of our star. It is the source of the sun's energy, the light and heat that bathe our planet. Every ray of sunlight that reaches us is a product of this incredible fusion process. Without the sun's energy, there would be no life on Earth. Plants rely on sunlight for photosynthesis, and animals depend on plants for food. The sun is not burning like a fire, it's something far more powerful. The energy produced by nuclear fusion is millions of times greater than that of chemical reactions like fire. It's a gigantic nuclear reactor, fusing atoms together and releasing unimaginable amounts of energy in the process. This energy travels from the core to the surface and then radiates out into space. Understanding this process is key to unlocking the secrets of the sun's future. Scientists study the sun to predict its behavior and to understand how it will evolve over time. Our very existence is intimately connected to the life cycle of our star. The sun's energy drives our climate and weather, and it influences the conditions on our planet. That's why understanding the future of the sun is not just an academic exercise, but a journey into the ultimate destiny of our planet and ourselves. The sun's future will shape the future of Earth and all life on it. Deep within the sun's core, the pressure and temperature are unimaginable. Here, atoms of hydrogen are forced together, overcoming their natural repulsion. They fuse to form helium, releasing a tremendous amount of energy in the process. Imagine holding two magnets, their same poles, pushing each other away. That's the force the sun has to overcome to fuse hydrogen. The energy released from this fusion is what powers the sun. It travels outwards, taking millions of years to reach the surface. This energy then travels through the vast emptiness of space. Eventually, it reaches Earth as light and heat, sustaining all life on our planet. From the smallest blade of grass to the tallest redwood, all life on Earth is powered by the sun's nuclear fusion. But this process cannot last forever. The sun has a finite amount of hydrogen fuel in its core. When this fuel begins to run out, the sun will enter a new and dramatic phase in its life. In billions of years, the sun's core will run low on hydrogen. This depletion marks the beginning of a significant transformation in the sun's life cycle, a phase that will dramatically alter its appearance and behavior. This is where the story takes a dramatic turn. The sun, which has been a stable source of light and heat for billions of years, will undergo a series of profound changes. As the core shrinks and heats up, the outer layers of the sun will expand dramatically. This expansion is a result of the core's increasing temperature, which causes the outer layers to swell outwards. The sun will swell to an enormous size, becoming a red giant star. This transformation will be one of the most visually striking phases in the sun's life cycle. Imagine a giant, glowing balloon expanding outwards. The sun's outer layers will stretch far beyond their current boundaries, reaching out into the solar system. That's what the sun will become, engulfing the inner planets, including Mercury and Venus. These planets will be consumed by the sun's expanding outer layers. Its once yellow light will turn a deep, ominous red. This change in color is due to the cooler temperature of the sun's outer layers as they expand. This transformation will be a slow and gradual process, taking millions of years to unfold. The sun's journey from a stable star to a red giant is a lengthy one, marked by gradual but significant changes. But the consequences for the inner solar system will be dramatic. The intense heat and radiation from the red giant sun will have a profound impact on the planets and other celestial bodies. The once life-giving sun will become a harbinger of destruction, forever altering the planetary landscape. The inner planets will face extreme conditions that will make them uninhabitable. As the sun expands, it will engulf Mercury and Venus, their surfaces scorched and vaporized. These planets will be completely transformed by the sun's intense heat. Earth's fate is less certain. While it may not be engulfed by the sun, it will still face extreme conditions that could make it uninhabitable. It might be pushed outwards, escaping complete annihilation. This outward push could be a result of the sun's changing gravitational forces, but even if it survives, the intense heat from the red giant sun will boil away its oceans, leaving behind a barren and lifeless rock. The Earth, once teeming with life, will become a desolate and uninhabitable world. The fate of our planet hangs in the balance as the Sun enters its red giant phase. The expanding star will dramatically change the habitable zone, the region around a star where temperatures are suitable for liquid water to exist. While the Sun grows, its luminosity increases. The once temperate Earth will experience a runaway greenhouse effect. Oceans will evaporate, the atmosphere will be stripped away, and the surface will be scorched. Life as we know it will be impossible. The once vibrant blue planet will be transformed into a desolate wasteland. But even as the inner solar system faces this fiery demise, the outer regions will experience a strange and unexpected transformation. The icy moons of Jupiter and Saturn, once locked in a perpetual freeze, may become habitable. Their icy surfaces could melt, creating vast new oceans. While the inner solar system bakes, the outer regions might experience a fleeting period of potential habitability, a testament to the ever-changing nature of our universe. The red giant phase is not the end of the Sun's story, but rather a dramatic transition. As the Sun burns through the last of its fuel, it becomes unstable. The outer layers, no longer held by the Sun's gravity, will be ejected into space. This expulsion of stellar material will form a breathtaking cosmic spectacle known as a planetary nebula. Imagine a giant soap bubble, its surface shimmering with vibrant colors. That's what a planetary nebula looks like, a cosmic masterpiece painted across the cosmos. These nebulae are not related to planets. Their name is a misnomer from early astronomers. They are the remnants of dying stars, their gaseous shells illuminated by the fading light of the stellar core. Within this expanding shell of gas and dust, the elements forged in the Sun's core will be scattered into the interstellar medium. These elements, the building blocks of life, will one day seed the formation of new stars and planets, continuing the cycle of cosmic creation. At the heart of the planetary nebula, the Sun's core will remain. No longer capable of nuclear fusion, it will slowly cool and fade over billions of years. This stellar remnant is known as a white dwarf. Imagine a celestial ember still glowing with residual heat. That's what a white dwarf is, an incredibly dense object about the size of Earth but containing a mass comparable to the Sun. White dwarfs are the final stage of evolution for stars like our Sun. They're incredibly faint and difficult to detect, their light a mere whisper compared to the Sun's brilliance. The white dwarf that will be the Sun's final act will slowly radiate away its remaining heat over billions of years. Eventually it will fade into a black dwarf, a cold and inert object, marking the end of the Sun's extraordinary journey. But even in its final state, the Sun's influence will continue to be felt, a testament to its enduring legacy in the cosmos. Though the Sun's life will come to an end, its story doesn't end there. The elements forged in its core, the carbon, oxygen and nitrogen that make up our bodies and our world, will be scattered into the vastness of space. These elements, born from the heart of a star, will become the building blocks of future generations of stars and planets. Like seeds scattered by the wind, they will carry the potential for life to new corners of the universe. Every atom in our bodies, every grain of sand on the beach, every drop of water in the ocean was once part of a star. We are, in a very real sense, star stuff. And when the Sun reaches the end of its life, it will return these elements to the cosmos, continuing the cycle of stellar evolution. The Sun's death will be a creative act, seeding the universe with the potential for new life. Its legacy will live on in the countless stars and planets that will form from its ashes. The life cycle of our Sun is a microcosm of the grand cycle of stellar evolution that plays out across the universe. This cycle is not just a series of events, but a profound narrative that has been unfolding for billions of years. It is a story written in the language of light and matter, a tale of creation, transformation, and rebirth. Stars are born in vast clouds of gas and dust known as nebulae. Over millions of years, gravity pulls these particles together, igniting nuclear fusion in the core of the forming star. They live for millions to billions of years, depending on their size, burning brightly and providing light and warmth to any surrounding planets. Eventually, they die, often in spectacular explosions called supernovae, scattering their enriched guts across the cosmos. This cycle of birth, life, and death is a testament to the interconnectedness of the cosmos. The elements forged in the hearts of dying stars are the building blocks of new stars, planets, and even life itself. Every atom in our bodies was once part of a star, making us intrinsically linked to the universe. We are all part of this grand cosmic dance, from the smallest subatomic particle to the largest galaxy. The same forces that govern the life cycles of stars also govern the formation of galaxies and the structure of the universe itself. This cosmic dance is a beautiful and intricate ballet that has been performed for eons. Understanding the life cycle of stars is not just about understanding the universe, it's about understanding ourselves. By studying the stars, we learn about the origins of the elements that make up our bodies and the processes that have shaped our planet. It is a journey of discovery that connects us to the very fabric of the cosmos. As we gaze up at the night sky, we are not just looking at distant stars, we are looking at our past, present, and future. The light from these stars has traveled across vast distances and immense spans of time to reach us, carrying with it the history of the universe. Each twinkling star is a time capsule, a glimpse into the distant past. We are witnessing the grand cycle of stellar evolution, a cycle that connects us to every star, every planet, and every living thing in the universe. This cycle is a reminder of the impermanence and continuity of all things, a dance of creation and destruction that has been ongoing since the dawn of time. The universe is a dynamic and ever-changing place, and we are fortunate to be a part of it. Every moment, stars are being born and dying, galaxies are colliding and merging, and new worlds are forming. It is a universe in constant flux, a cosmic symphony that we are privileged to witness. By understanding the life cycle of stars, we gain a deeper appreciation for our place in the cosmos and the interconnectedness of all things. It is a humbling and awe-inspiring realization that we are part of something much larger than ourselves, a vast and intricate